Look at these three projects: a simple calculator app, an online shopping platform, and the navigation software for a space rocket. If a team is assigned to build all three, the immediate question is whether they can approach them the exact same way. A basic calculator app can be coded by one person in a few hours, but rocket software requires years of planning, simulation, and strict verification to prevent a catastrophic failure. In biology, complex organisms follow a strict sequential life cycle. A butterfly always develops from an egg to a larva to a pupa before finally becoming a butterfly. The stages are predictable and immutable. Software engineering has a digital equivalent. The Software Development Lifecycle, or SDLC, is a structured framework that dictates every phase of a program's creation, guiding it from an initial idea all the way to a finished product. Without this framework, development teams often fall into chaotic coding loops. As requirements change midstream, they are forced into repeated rewrites and bug-fixing cycles, leading to the very delays they were trying to avoid. Before breaking down the specific phases of the SDLC, we have to distinguish the overarching framework from the individual tasks happening inside it, what engineers call a software process. Think about cooking a meal. Washing and cutting vegetables are isolated activities. In software, these are your individual processes, like writing a specific function or running a test. The SDLC is the complete recipe that dictates exactly when and how each of those activities should happen. Writing code is a single task. Software engineering is the systematic management of the master sequence that orchestrates the entire build. This master sequence begins with three foundational phases. First is planning, where teams calculate project feasibility and budget. Second is requirement analysis, where they extract the exact needs of the customer. Third is design. During the design phase, engineers map out the system architecture, lay out the user interface, and structure the database. Notice that no actual coding happens here. It is entirely about creating the abstract blueprint. The abstract design is only translated into a working application when we cross the threshold into Phase 4, implementation. Here, developers write the actual program. They define the blueprint and code, allocate memory for the specific data, and execute the system commands that make the application function. Once the code is written, the software moves to testing to hunt down inevitable human errors in performance and security. After it passes, it reaches deployment, where the software is finally released to live users. Now consider, if users are actively downloading and running the application, is the project actually finished? What happens when a user discovers a crash on a specific device? That reality brings us to Phase 7, maintenance. This is the longest, continuous phase of the lifecycle. Developers fix bugs, improve performance, and add new features. True software is never strictly done. Rather than memorizing these 7 phases, map them to a physical progression. If you are building a school, you cannot paint the walls before pouring the foundation. Software development follows that exact same logical order. This structured order exists to meet specific business objectives. It allows for accurate planning, ensures high quality through consistent testing, lowers unnecessary costs, guarantees timely delivery, makes future maintenance easier, and keeps communication clear between the developers and the customer. So, if you need a strict, exam-ready definition, SDLC is the structured framework defining all the phases involved in developing software, from initial planning straight through to long-term maintenance. But this raises a final question. Does every single software project, whether it's an app for a local bank, a fast-moving startup, or a theoretical research lab, have to follow these 7 phases in the exact same chronological order? The phases themselves are universal, but the strategy of execution changes based on the project's specific needs. That leads us to the oldest and most rigid execution strategy in software engineering, the waterfall model.